2019. And another important point is he is a first generation entrepreneur. He did his masters in industrial engineering from PSG in 1984. He started manufacturing the first cooling tower in South India and also the refrigerator dryer as well as cooling towers. In 1990 he started making chillers, which was discontinued and again the industry started. He is also involved in the OE business with major compressor manufacturers like LG, Atlas Copco, Kaiser, Fujifilm, etc. supplying the products, and he is #1 dryer manufacturer with the capacity to make 9,000 dryers a year. Please change before it is too late or before your wells run dry. This is very much required for water conservation. So he has done a lot of work on how to save the water also. So in this presentation he will talk about energy efficient cooling and water conservation in molding application.
Thank you. Good morning to you all. So good morning to you, all of you. Morning there was a talk about sustainability and making plastics better. To make this sustainable process to work further, we have to look at two requirements which are very mandatory: energy saving, and also we need to look at the next generation for water conservation. So my presentation will be a brief presentation about these two aspects. So a little 2 slides about the history of the company, what products we make, and then I go into the cooling systems and chiller and benefits and energy saving case studies, and for water conservation, adiabatic cooling. So we started the company way back in 1984, and we have a large history of making products in various stages, ISO 9001 and things like that. So in fact, we have last 2 years we are concentrating on manufacturing of fluid coolers, adiabatic fluid coolers for various applications. So that is we have two basic companies. One is Gem Equipments, and Gem Orient Machinery is another company where we have 50% Japanese, 50%. It is a joint venture company with the Orient Machinery of Japan, which is an 80-year-old company. So if you see the last step, we started manufacturing the chillers in 2017, and we have developed a lot of precision inverter chillers based on the design and technology from Japan. And in this year we will cross about 800 machines what we have supplied for various applications. Not only for plastic molding, we give for machine tool, Tata Electronics. So a lot of customers are available for these products. So just to give an overview of our products, we make all accessories for compressed air, aftercoolers, receivers, dryers, filters, desiccant dryers. Similarly, the full range of cooling towers we have. So we are the only company in India who can give the entire utility solution for cooling. Means cooling towers, various types, low noise, high temperature, modular, large capacities, dry cooler, adiabatic cooler, as well as large fin fan coolers. So basically the industrial cooling can be divided into two major applications. One is cooling using or consuming water, that is by using sensible heat. So those are general applications, normal cooling towers like that. But let's go to the next slide. Yeah, this is a typical manufacturing setup what we have. All our processes have been validated as per JA standard by our Japanese collaborators. So we have various testing facilities, we have environmental booths for testing various models of chillers at full capacity. So all products what we made are fully tested in the factory. Now types of cooling system. Basically cooling system can be divided into two. One will be a open cooling, another will be closed loop cooling. So open cooling means normally we have conventional evaporative coil type cooling tower, adiabatic cooling tower, that is typically an open cooling only in terms of evaporation, wet cooling tower and wet cooling tower plus dry combination. We have various options for conserving water. Then in closed loop, we have adiabatic cooling towers, dry coolers, and where some specific application calls for lower than wet bulb temperature, we need to go for chillers. So basically the concept of chilling comes in with respect to our wet bulb temperature, not the dry bulb, not the ambient. So based on the wet bulb, whatever temperature is required, will decide what kind of cooling we need for the application. So normally when applications are there which is beyond the wet bulb, that is suppose our wet bulb in Chennai is 28, you need 32, 33 degrees, then conventional cooling tower should be okay. But if you are able to accept water temperatures, cooling water temperatures above the ambient, that means let us say our maximum ambient Chennai is 40, there are a lot of applications where you can manage with 44, 45 degree cooling water temperature. In those cases, you can directly use a dry cooler. And if the process application like a mold, you need lower temperature than the wet bulb, then you have to go only for the refrigeration chiller. So what exactly are the current customers looking for? Customers are looking at the option of running the process completely without any water, that means zero water loss. So that is one of the requirement customer wants, because that brings in the sustainability in the process. Comparatively low power consumption with respect to quantity of material produced. We should be able to reduce the cycle time to get higher productivity. Also, customer needs accuracy so that the product consistency will be maintained, product quality consistency. Then lower, if you use a closed loop cooling, then there is no question of any maintenance or any scaling, descaling and all those things. And also people look at the lower initial cost, or maybe we can say even the lower cycle time, cycle cost, total life cycle cost, sorry. So typically the chillers can be set anywhere between 10 to 30. Normally the chillers can be set only between, the normal on-off chillers can be set only at higher temperatures, whereas our chillers have got a very wide range of operation from 10 to 30. So even 30 also, the compressor will run within the envelope. That means it is a highly wide range of operation what we have for various applications. Then zero water loss, because chiller has a closed loop, so no water losses. And by using suitable thermal valve system, we can use the same water for both mold as well as the power pack, hydraulic power pack cooling. So this shows a typical product placement for accuracy. Compressor on-off will be low accuracy. PID controller will be little better accuracy, whereas our chillers will operate at plus minus 0.5 degree accuracy. So the whole world is moving towards net zero climate goals. So energy efficiency is the first fuel and the main route to net zero. So by adopting the inverter chillers instead of the for cooling both servo system as well as the molds, we can completely eliminate water from the process of molding. So a lot of customers have adopted that technology. Also, the chillers will have a permanent magnet motor, which will be a IE5 specification winding on the compressor. So the COP of the compressor will be very, very high. So because of that, there will be a consistent enhanced productivity due to consistent water temperature and oil temperature throughout the operation, throughout the season. The quality, the product quality also will be consistently maintained. And the capital cost also can be optimized by avoiding remote cooling tower, complicated piping, again distribution to various machines. So all those things can be avoided, so that single chill water can be used for both cooling as well as hydraulic power pack cooling. So this gives benefits of the inverter based chiller for molding application. So low product cycle time because you can run at accurate temperature, high better power saving, wide operating range, highly reliable, and you can use common chiller for multiple machines. Additional benefits are, since it is a inverter based system, the starting current will be very low. So you can have smaller generators for standby. So generator capacity can be low. And also, most of the hydraulic machines now come with servo cooling. So the servo cooling heat rejection will be almost 40 to 50% lower than the normal standard motors power packs. So the chiller loads can be reduced. And we can connect multiple chillers in modules so that there is no, even though it is modular, we have no restriction in the capacity of the chiller. So this is how typically a chiller is connected. Normal typical system, mold is connected to chiller and cooling tower is connected to the power pack. Whereas if you can use a chiller with a thermal valve, we have shown a thermal valve system. So the oil temperature can be accurately maintained based on the chill water temperature. So suppose there is a larger capacity, we can have this kind of arrangement by which we can have a large sump and use multiple chillers for controlling the capacity. So maybe you can have partial standby, the running costs can be drastically reduced, water can become zero in that case. So this is also a typical chiller application for heat flow through hot well, cold well, and through maybe intermediate plate heat exchangers where the water quality is bad. So typically the case studies what we have seen is for a 48 cavity mold where an existing unit was replaced by our standard inverter chiller, we were able to save almost 6 units per hour. So obviously the payback on the equipment will be very quick, maybe less than 2 years. So for caps and closures, this is one of the typical application. Almost 5-6 units we were able to save on the capacity. In thin wall, almost same capacity, 20-year existing chiller replaced by chiller 2 was about almost 6-7 units, almost 4 to 5 units we can save. And this is the typical data given by customer. So this shows the specific power consumed per kg of his consumption. So based on this, you can see that all these red steps are Orion's power specific power ratings. So replacing of 15 TR with on-off chiller with a 7.5 TR chiller, we were able to save around 4 to 5 units. ISBM DPW machine, DPW and DPH machines, these two. And now moving to conservation of water with adiabatic cooling tower. Now adiabatic cooling tower is a concept by which we add environmental pads or adiabatic pads before the radiator, so that the radiator can be selected suitably and the closed loop system can be maintained at wet bulb plus 3 to 4 degrees, similar to a cooling tower. So how it works is basically the ambient dry bulb temperature is what will determine the process temperature in a dry cooler. But once you reduce the inlet temperature to the radiator, then automatically you can achieve lower than ambient temperature in this case. So this gives a typical arrangement of the dry cooler. So hot air is going and a small quantity of water is evaporated. Here there is a water loss, which will be partial when compared to the normal cooling tower evaporation. So these non-metallic pads provide an efficient coverage area. Mesh is front of the heat rejection area. So the fixing brackets and other options are available. The mesh pads are available in modules, so they can be in replacement or service. You can replace parts of the radiator. So this drastically reduces the running cost by saving water, because today water is becoming expensive. When you consider the water cost at rupees 10 to 12 or 15 per liter, the payment, if you if you have a new investment, the paybacks can be faster. So reduced water consumption and energy efficient compared to dry cooling, and it is really compact with lower operating cost and highly environment friendly. So this is how typically we install the system with an adiabatic fans. So conclusion, the inverter chiller delivers the cooling capacity with very low energy consumption. Due to high reliability, the productivity is better, so in lowers life cycle and consistent product quality. Zero water losses when compared to the conventional chiller with cooling tower system. Achieving the required temperature up to 30 degree across all seasons. Requiring smaller servo stabilizer or a starting generator. And you can connect in modular fashion up to 12 units. Suppose 30 PR mix into 12 360 PR can be connected in modular. And it has already got a smart control system by which one will act as a master, others will act as slave. Similarly, the process water temperature with varying loads can be up to plus or minus 0.5 degrees centigrade. So because you are giving a very consistent temperature to your process, the quality of whatever you produce also will have that accurate quality of finish. And all these equipments are designed to work for 50 degree ambient, so you don't have to go for a water cooler which conventionally people are using. And by properly suggesting piping sizes, a lot of energy can also be conserved on the pumping pressures. So in adiabatic cooling, it delivers the cooling capacity with very reduced loss, achieving evaporating very low water. Also, similarly, it can maintain consistent temperature across all seasons. In cooling towers, normally we have chemicals being added that is again not sustainable for the environment. So, algae formation and all these things can produce respiratory problem for the operator. So, all these things are avoided. Similarly, since we are having a closed loop cooling, you don't need to do any maintenance, descaling on the heat exchangers, hydraulic power plants, bolts, and all those things. See, basically, whatever 780, 800 machines, whatever we have supplied, we have roughly calculated, and we proudly can say that almost 17 megawatt of energy we have saved in the last 4 or 5 years, and also millions and millions, because I don't know the value, maybe millions of liters of water could have been saved. Thank you.
Nice to know so much saving has happened, really. And let's look at the question for the session.
Very interesting presentation in this. There was a reference to a 48 cavity mold. Basically, can anyone tell us what was the power saving in units?
Yes, close to 6 units. Next.
We have the point something good.
Is it 18 units?
Okay.
Is it 18 units? No. Is it 12? No. Huh? Is it 0.45?
No.
No.
6.1.
Can you repeat the question once again?
6.1, he is telling correct.
Oh.
Yeah.
Okay, 1 minute.
Thank you, sir. 6.1, yeah. See, I'm Jenu from Bharat Bijli. So the answer is 6.1. Thank you.